Hello, Alex here, and in this video in my series on mastering Harman Phoenix, I want to talk about developing Phoenix in the ECN-2 chemical process and see how cross-processing in this way compares to standard C41 development. At the risk of being a bit clickbaity, although nothing revolutionary, I was quite surprised in a couple of ways. So let's get into it. In part 1 of this series, I talked about Phoenix and C41 development and covered a lot of topics like how underexposure causes increased coarser grain and how pulling and push processing work, as well as some more general information about this overall project. So if you haven't watched that video first, please do check out at least the first section because it gives you a lot of context that's very important for this video. In this video though, I want to compare Phoenix at +0, so box speed, a -1 stop pull, and a +2 stop push in both C41 and ECN-2 and see how those two processes compare with Phoenix in terms of color shifts, effective film speed, contrast and dynamic range, and grain and resolution. The ECN-2 process is the second generation of the Eastman color negative process used for movie film. So everything from 50D in a Super 8 camera to 70mm 250D that Nolan used for Oppenheimer. This is a different process than the standard C41 chemical process, and developing any film in the opposite process or a different process is considered cross-processing. Cross-processing the cinema films in C41 is extremely common, most famously with Cinestill's products, 400D, 50D, and 800T, which are at their heart the Vision 3 cinema films but without remjet, enabling processing in the C41 chemical development process that doesn't have a remjet removal step. But you can also go the other way, developing standard C41 film in the ECN-2 chemical process. When developing any film, whether it's an ECN-2 film or a C41 film, in both the C41 and ECN-2 processes side by side, you would generally expect to see three things: reduced contrast in the ECN-2 negatives, some level of color shift between the two images, which will vary depending on the film, and a reduced overall density in the ECN-2 negatives corresponding to a reduction in effective film speed, as in a lower true ISO. When you develop a color film, the color developer or CD reacts with the silver ions in the silver halide grains to form metallic silver, which later gets bleached away, but also creates the oxidized form of the CD, and this reacts with the dye couplers within the film, forming the corresponding cyan, magenta, and yellow dyes that make up the various parts of your image. What's important is that the CD in its oxidized form becomes part of the final dye, so using a different CD gives a different chemical structure to the final dye molecule, and a different chemical structure means different absorption patterns, different absorption spectra of those dyes, which means they have slightly different colors. It can also mean that they have different intensities or molar extinction coefficients. They're basically more or less potent depending on these minor chemical changes. The C41 chemical process uses the most modern color developer, CD4 or color development agent 4. Versus the E6 and ECN2 processes, which both use the older CD3. There's nothing inherently good or bad about using one or the other. These processes are defined around using one or the other. The important part is that using the C41 developer, you're going to have CD4 reacting with the dye couplers of a given film to form one set of dyes, and then using the ECN2 development process, you're using CD3 to form a very slightly different set of dyes from those same three dye couplers. And that's what gives you the overall color shifts that you see in your image, because you're going to have slightly different absorption or slightly different intensity in your dyes. When I used the E6 color developer before, just the color developer, not a full reversal process, to produce negatives, I had a horrible orange cast and disgusting grain when I used it with Phoenix in part 2 of this series, but Megatoni Production in Kowloon did some ECN testing just after launch, and their negatives looked fine, so I wanted to have a closer look and think about why the CD3 from one development process would work fine, but not from the other. With Phoenix, the negatives developed in ECN2 have a reddish pinkish cast, and red is formed by the combination of magenta and yellow dyes with relatively less cyan. That should make the scans lean a bit more teal or aqua after inversion. This shows just how differently a given developing agent can behave, and this makes sense if you're familiar with how black and white developers work. All black and white developers essentially boil down to 6 or 7 different developers: hydroquinone, catechol, pyrogallol, metol, phenidone and its derivatives, 4-aminophenol and 1 or 2 others. But we have dozens if not hundreds of different developer formulae because it's not just the color developing agent that matters. What I think is going on here is that in the E6 chemical process, you have your original development and then reversal. I went through all this in part 2 in a lot more detail if you want to learn about how this really works. And then the color developing step. This color developing step is carried out to completion in the E6 process, meaning you get the maximum amount of development. You know, you're developing every dye coupler molecule in the cyan layer, the magenta layer, and in the yellow layer in the film. With ECN-2 and C41 equally, we're not developing to completion, because if we were, then over-developing to push would not be possible, because there would be no dye couplers left over. And what I think is happening is that in the E6 process, the CD is basically a nuke of CD3 that just blasts it, and it doesn't make a difference if the developer, or if the layers aren't developed evenly, because they're all eventually going to catch up at some point because you're developing to completion. Whereas in the ECN2 process, it's more restrained and balanced, trying to maintain even development of the different layers. I only have 2 hands, but you get the general idea as you increase the density during the development process. And in this case, I think this is giving us a much more nuanced, balanced overall image versus that kind of nuclear CD3 from the E6 process. As for what specifically is causing that, who knows? pH, temperature, concentration, various additives, 100,000 other things realistically affect dyes, and dye science is an incredibly broad and mysterious area of chemistry and physics. It's very hard to summarize in any concise way, but just know that even though they have the same developing agent, the formula is different, so the results shouldn't necessarily be the same. I think it's fair to leave it there. There is an overall teal tint in the ECN2 images, both in the extreme highlights and in parts of the shadows, and the overall saturation is a bit higher than the C41 images, which kind of surprised me. This tint is very easy to correct though, with very slight curves and hue adjustments, and just like in my video on the purple base tint, I only gave myself a few seconds to work out a very coarse adjustment, just to prove that it could be dealt with very, very quickly. Obviously I could do it if I gave myself 5 minutes or something. And something else that was very nice is that this correction applied very nicely across all of the other images in this video, though you won't be seeing them corrected. I'm only showing the correction in this comparison here. Just know that whether I underexposed, overexposed, pushed or pulled, more or less the correction needed was about the same. So it seems consistent for the ECN2 process, which is nice if you're trying to work out a process for this for yourself. I know very little about densitometry and sensitometry, so this is just a practical evaluation of film speed, as in, I'm looking at the images and telling you what EI or ISO setting I think works the best. I'm far from the only person who does that in the real world, but just to know that I'm not actually measuring the foot speed if you're into that kind of thing. That sounds weird now that I say it, but I mean in terms of HD curves and your log of exposure. Overall, the ECN2 negatives are thinner than the C41 negatives for a given level of exposure, which makes sense and is what we expected. When developing in C41, I found that the best EI or ISO setting most of the time was between 200 and 125, depending on the contrast in your scene, for normal +0 development, about 100 for a 1-stop pull, or about 500 for a 2-stop push because it doesn't push supremely well. Let's see how that compares in the ECN2 process. When developed normally compared to this shot at 200 in the C41 process, shooting at about 125 seems the best balance in ECN2 between retaining both shadow and highlight detail, so we're looking about a 2/3 of a stop speed loss. In the real world images that you'll see at the end of this video, which I shot at 125, that seemed to be a bit much on an extremely bright sunny day, and maybe 160 would be a better choice, but I wouldn't recommend shooting at 200. When pulling 1 stop, compared to the image shot at 100 and developed in C41, I'd also recommend shooting at 100 for a 1-stop pull in ECN2. So here it looks like there's essentially no speed loss under pull processing conditions, at least compared to C41. When testing the film speed, I originally did a test in 1-stop steps and then dialed it in with 1/3 stops to get my finer increments. I didn't do the 1/3 stops for the pushing because neither process works particularly well for pushing, but you'll see the images themselves are a bit coarse and it's not really that good an idea. Since I don't have a C41 photo at 500, we'll use the one at 400, even though it's a little bit hot. And surprisingly, I think the best option for a 2-stop push in ECN2 is between 200 and 400, maybe about 250. This result does make sense though. The ECN-2 developer is an overall lower contrast developer than the C41 developer, so there are two ways you could think about it. Either you're going to have your highlights stay where they are and the shadows are brought up, reducing the contrast between them, or you're going to have your shadows stay where they are and the highlights just won't go up as high. And that is what is happening here. We're effectively seeing a reduction in Dmax for a given Dmin, to talk a little bit about densitometry and sensitometry, which overall means that you're just not really gaining much speed and you're not able to push as effectively. You're still losing your shadow detail, but you're not even getting the highlight detail that you get with the C41 process. So overall, pushing Phoenix isn't a great idea anyway, although I do like it, it just doesn't technically perform well. ECN2 pushing is definitely not the move. You know, we're talking about shooting the film at maybe EI or ISO 250 with a 2-stop push in ECN2 versus 200 in standard C41. It's really not worth it. You're not gaining much film speed. But also the non-linear increase in film speed, as in not gaining a full stop when you overdevelop one stop, that's far from exclusive to Phoenix either. If you check the website for Cinestill's 800T, they say the same thing. Now they give you more broad ranges rather than fixed values, which is quite helpful. But they, in principle, are recommending a 3-stop push for rating the film at 2000, which is barely more than a stop and a half. But just to say that this isn't some like obscure failure on Phoenix's part, you know, this is actually quite a known thing, just not something that most of us would encounter very often. ECN2 negatives have lower contrast than the corresponding C41 negatives because the ECN2 process has a lower target gamma or target contrast. This is to retain as much information as is humanly possible in the negative for grading and scanning later. In the real world, this works out to about 16 stops of dynamic range for well-developed and well-exposed ECN2 cinema film, which is 2 to 4 stops higher than the best digital stills cameras on the market today, which is absolutely ridiculous. Phoenix is a very high contrast film, and we've already seen that pushing an ECN2 process doesn't really bring the shadows up, so the thought I had was, what about bringing the highlights down to increase the effective dynamic range by bringing the contrast kind of within the film's dynamic range, so to speak, in much the same general way as we did with pulling in the C41 video. As far as I can tell, this is also the cause of the reduction in film speed in ECN2 versus C41, but I'm not really qualified to talk about that, which is why I didn't go into it in any depth in the film speed section and why I'm not here. There is an equivalent curve for contrast and gamma for a film, and they are measured individually for a given film and also individually for a given color channel in a color film. This is what all 6 curves might look like for some random color film in both the ECN2 and C41 processes, just as an example. Comparing the best photo from each set and developed normally at +0, the photos look on par at a glance, but a closer look shows that the ECN2 highlights aren't as bright and the shadows aren't as dark. In the images that are pulled one stop, it's pretty much the same story, but I do want to focus on one extra thing: halation. When I did my original C41 video, I saw that when we pulled the film, the increased exposure caused increased halation regardless of the underdevelopment. Generally speaking, you would expect that halation is an exposure phenomenon and not a development phenomenon, but there is an asterisk here because we're cross-processing. I mentioned that the negatives themselves have an overall reddish tint, and that corresponds to an overall teal or cyanish tint in the scans after you invert those negatives. So okay, we have relatively little cyan compared to the magenta and the yellow, but what's the complementary color of cyan? It's red, and we see an apparent reduction in halation, which I was not expecting at all, because there's relatively little density in the cyan layer corresponding to the red channel, so the red is effectively desaturated, reducing the apparent halation in spite of the increased exposure in the pulled images. The difference is definitely there and noticeable, but it's not so tremendously huge, and it's not really noticeable in the +0 box speed images, only really when pulling because of the increased exposure. So I would expect that you're only going to see this benefit in ECN2 when you're either overexposing the film or shooting a very high contrast scene where your highlights are going to be very bright and there's going to be a lot of halation anyway. You would just see less than when you're shooting developing in the C41 process. Lastly, for the shots push 2 stops, I don't have a great comparison. As I said before, it's about the same as the kind of box speed shots with darker highlights and brighter shadows, but the effect is smaller because pushing just adds so much contrast that you're kind of overpowering the contrast reducing effect of shooting in ECN2 in the first place. When I was using the E6 color developer to make negatives, I got that nuclear orange cast, but also tremendously coarse grain. But again, I think that the difference in purpose and formulation of the CD3 solution, this color developer for both E6 and ECN2, can explain why they behave so differently, especially given that the grain size in E6 is controlled mostly, if not completely, by the reversal step, as I showed in chapter 2 of this series. Developed normally, the ECN2 shots have slightly finer grain and interestingly higher acutance. Acutance can basically be thought of as perceived sharpness and how our brains perceive the resolution in the image, but it isn't the same thing as the actual resolution in terms of detail. Sharper, higher contrast transitions between fine details cause an increase in apparent acutance. Think about using a developer like Rodinal versus a developer like Xtal for black and white film. You can see in the frame of the whiteboard and the text on the Bellini box that the fine details are just that bit clearer. In the pulled shots, the difference is a bit smaller, maybe because that one-stop pull just makes such a difference for the C41 images and it kind of brings them closer together, but there's definitely still more definition in the fine details of the ECN2 pull. This is the other reason that I did 2 sets of ECN2 test strips, in whole stops and then 1/3 stops, because I wanted to replicate this and be more careful, use a narrower aperture, a heavier tripod, use a tape measure to make sure everything was as planar as I could reasonably get, just to rule out any me problems. And yeah, sure enough, I was able to reproduce it. And Phoenix is actually quite a bit finer grained at box speed and has much higher acutance in the ECN2 process than the C41 process, which is quite interesting. Whether that's down to ballasting and bleeding or interlayer effects, I have no way of knowing. Lastly, when pushing 2 stops, both are very grainy, but the ECN2 shot is better, again, because the C41 image just kind of falls apart a bit quicker, where the ECN2 photo kind of holds itself together a bit better. So to summarize this chapter of the project, ECN2 seems like a great option for Harman Phoenix, and it certainly has some distinct benefits over the ECN2 process. There is a level of color shift, and it's very easy to correct, but also extremely consistent regardless of degree of development, but also degree of exposure. Sure, you can probably dial it in a little bit, but a very quick approximate correction factor, so to speak, or a preset in your method if you wanted to go down this route using ECN2 for Phoenix, would serve you very well for the vast majority of your images. There is an overall shift towards that teal color because of a relative lack of cyan in the negatives, whether that's because the dye isn't formed as effectively, or more likely it has a lower molar extinction coefficient, so it's less potent and intense as a cyan dye. This causes a shift towards red in the negatives, causing a shift away from red in the scans, which causes a reduction in apparent halation, because the halation is effectively less saturated. It doesn't completely eliminate it, and you can still see it, but it's definitely not as bad as I've seen in a lot of images of Phoenix shot on bright sunny days. I mean, summer is just starting here now. I haven't been able to shoot Phoenix on a day like this yet in the C41 process, but I've seen a lot of pictures from a lot of people. People have sent me pictures for opinions and just general critique and feedback, which I'm quite flattered about. So I kind of know what to expect, and it definitely performed very well. Another way that the ECN2 process really benefited Phoenix was in terms of contrast. By using a lower contrast process that reins in both the highlights and the shadows, you kind of capture more detail from a given scene within Phoenix's dynamic range. So you're effectively increasing the dynamic range of the film by reducing the overall contrast. You're able to capture quite a lot more detail. Again, I've said this before, nothing is going to turn Phoenix into Ektar, Portra, Pro 160NS, Velvia. That's never going to happen. But this is a significant improvement in both terms of like actual color, reduction in halation. I say color because it's so easy to correct. It's basically a non-issue, like the purple base. The increase in overall dynamic range from the reduced contrast. The reduction in film speed being not such a big deal. You are seeing some level of a loss. I think 160 to 125 for box speed shooting, or 100 to 125 for a pull. Probably 100 would work well. I was only able to try box speed in the real world because my ECN2 chems died, so I had to send the film to Dev My Film down in Cork, and they developed it for me. But the last thing is that the ECN2 process gave an overall higher acutance or apparent sharpness to the images, especially at box speed or when pushing. Not so much when pulling, but especially at box speed, the difference is quite substantial, and there's quite a bit more fine detail and a bit more Michael contrast, let's say, to the images. That just makes them a bit more bitey and a bit less smeary. As for why that happens, I don't actually know. But this was my first take doing this part, and that was actually quite good for a single take. I'm trying in these videos, or as I go on, to do longer single takes and not constantly have jump cuts, though sometimes I have to and I have B-roll and whatever. That was actually quite good. I think I covered everything I need to say there. So stay safe, and bye-bye for now. If you don't already, follow me on Instagram at Shaka1277 for new pictures every day. If you liked this video and enjoy what I do on the channel, please consider subscribing or checking out my Patreon, where the tiers start at just €1 per month.